question number 36. We need to find out the potential difference between point A and B in these two circuits. So this circuit looks like a special case of multiple voltage source connected in series. And to do this problem, we are going to convert this problem from this one to something like this. 3 voltage sources connected with 3 equivalent resistors in their series. And we are going to produce a formula, and we will actually derive this formula on the spot. And the formula is, this circuit can be replaced with a single source with equivalent resistance of 3 parallel resistors and a voltage source, and that voltage source is given by sigma EI divided by RI divided by sigma 1 upon RI. So let's prove this real quick so you don't have to memorize or in case we forget, because that's the one thing that's going to be used in this figure. So we have shown n EMFs of voltage E1, E2, En with series resistor R1, R2 all the way to Rn connected in this fashion. Let's say the voltage between A and B is V. Then this voltage can be, and let's say the current I1 flows out of this, I2 out of this, and so on and so forth, In out of this. Then this voltage V can be expressed for this particular line as this V is equal to the voltage E1, and the current flowing through this is I1, so this V is equal to epsilon 1 minus I1 R1. It's R1 here. In the same way, the voltage across this is same V, can be expressed as E2, and then current across it, drop across it I2 R2, and so on and so forth. We can express this voltage as V is equal to epsilon n minus Rn Rn, In Rn. Now these currents I1, I2, and so on and so forth, In, they combine to make current I, which is given by the sum of I1 plus I2 plus In equal to 0. Now, since this is open circuit, we have not connected any external resistance, so this I must be equal to 0. No current is flowing out of this. What it actually means that if these voltages are not equal, then one of the voltages that will be lower, in that case the current direction will be reversed. So some of these I values will be positive, others will be negative, and if you add all of them, they will come out to be 0. So we applied this principle to this. I can be replaced from this equation. I is equal, take this one to the left hand side, I1 R1 is equal to epsilon 1 minus V. So I1 will be equal to epsilon 1 minus V divided by R1. We replace this value of I1 with this. I2 in the same way we can replace I2 with epsilon 2 minus V divided by R2. And so on and so forth. In the last one, we have epsilon 1 minus V divided by Rn is equal to 0. We collect all the epsilon 1 terms together. We get epsilon 1 upon R1 plus epsilon 2 upon R2, epsilon 1 upon R2, epsilon 2 upon R2, and epsilon n upon Rn, minus V upon R1 minus V upon R2, and so on and so forth, minus V upon Rn. So we can write it this. From here, we can get the voltage V as epsilon 1 upon R1, epsilon upon R, epsilon 2 upon R2, all the way up to epsilon n upon R1 divided by 1 upon R1 plus 1 upon R2, and so on and so forth, 1 upon Rn. We can write this term as sigma EI divided by Ri, where R varies from 1 to n, divided by sigma 1 upon Ri, where Ri varies from 1 to n. So with this proof, and this is something is easy to remember, we can write this whole thing as the voltage between these points A and B is given by epsilon 1 upon R1 divided by epsilon 2 upon R2 divided by epsilon 3 upon R3, where epsilon 3 is the additional voltage source we have added to calculate our problem. Now this epsilon 3 is 0 because there is no voltage source over here. So this terms goes away, and we have the VAB as epsilon 1 upon R1 plus epsilon 2 upon R2 divided by 1 upon R1 plus 1 upon R2 plus 1 upon R3. If you want, you can simplify it a little bit like this. R1, epsilon 1 R1 R1, epsilon 2 R1 divided by R1 R2 plus R2 R3 plus R1 R3 multiplied by R3, because R1 R2 cancels from this and O3 R3 remains. Now the second part of this question, this one, if you look closely, this is the voltage source and this resistor is in series with it. So if you mentally remove this whole circuit like this and make this E1, so think about this. This E2 can be assumed to be the same as this. This R is in series with this, and then we come to the point B. And finally, this point R3 is the same as this, and this voltage source and R is the same as these two. Except that these two are reversed, but it does not matter. So by rearranging the terms, rotating it and rearranging the terms, this circuit is essentially the same as this circuit. So the voltage between A and B in this case will also be the same as in this case.